So, we've seen this slide before. The million-dollar question is, what is the best breed for the United States as we look at where we plug these in? Well, and it comes back on, it depends. And we talked about how it affects production environments, can affect the performance of specific animals. And so one thing I want you to understand is what a genotype by environment interaction is. And so with that, what it means is production environments affect the performance of all types of cattle. And so, for example, we're going to have variation in relative performance of different genotypes from one environment to another. And we know that phenotype is equal to genotype plus environment there. And so we've got these interactions that occur among different breeds. And so superior cattle for one environment may not be superior for another environment. And it could be as simple as one superior breed for one environment may not be in another. And that's the most common way that we look at it. But we also know that we can, over time, take cattle from one environment. And so, for example, there's an old study out there where they took cattle that were raised for generations in Florida and then moved them up into Montana. And they took cattle that were raised for generations in Montana, Hereford cattle, same breed, and took them to Florida. And there was a genotype by environmental interaction. So the Florida cattle didn't perform as well. Florida Herefords didn't perform as well in those cold climates. And then the Montana cattle didn't perform as well in the hot, humid Florida environment. So we can see some within breed effects. So we have to be careful in moving cattle, for example, that may have been genetically they selected for over generations up north, and we move them into maybe an extreme climate or environment down south there. The big thing we look at a lot of times is the breed effects. And so as you can see in that picture there, I took that picture there of some Charolais cattle there in the pond trying to cool off in May. Versus on the picture on the right, similar genetic breed type. We've got a British Continental on the right, and those cattle are doing exceptionally well. That was spring break for me about 15 years ago up in Colorado, just northeast of Denver. And so you can see those cold conditions, but those cattle are doing well in those conditions because they're more suited to those environments there. So we have those differences. And what I always like to tell producers is, yes, I can make straight British straight Boss Taurus cattle perform, and they'll survive maybe on the coast. And then I can also make straight Brahman cattle, and I can take them to Nebraska, calve them out in January, and make them survive as well. But for those cattle to survive up there, I'm going to have to put them in a barn with heat so that they will survive. And when I do that, my production costs go up. If I take those Boss Taurus cattle and I take them down to the coast in those hot, humid environmental conditions, most likely the reproduction is not going to be as high and their survivability is not going to be as high. So again, our production costs go up. So as we move animals farther away from where they're adapted, we get these interactions, these genotype by environment interactions, but ultimately we increase our production costs because of that. So we have to be careful with that. This is an example. This was a ranch over in northeast Texas, and I like to show this picture because there's varying percentages of Brahman influence in these cattle. They started off with Beefmaster cows, they started utilizing Angus bulls, and they started keeping those replacement females. Those subsequent generations of those cattle that were not as adapted to what it was a creek bottom where it was hot and humid in that area, they just didn't perform as well. They were harder, and so this rancher ended up trying to plug back in some Bos indicus genetics into that cow herd there. So what breed type? Well, we first say match the cow to the environment that you're in. So whether it be West Texas, South Texas, East Texas, Nebraska, Florida, figure out what breed type fits well in those environments. And then figure out what breed of bull that best complements her genetics to produce a calf that fits a specific market. And whether that market be a high red meat yield, a high quality market, CAB would be an example, a quality yield combination could be an example, or specifically for, again, a lot of our ranchers that are marketing their cattle directly off the cow, whether it be direct to an order buyer or maybe through the auction market, it's the calf that the order buyers want, that the industry is wanting today. And so that's kind of the game plan, what we do there. But match the cow to the environment. I don't care where your environment is. This picture was taken on the Spade Ranch in New Mexico. A little smaller type cow, predominantly English Continental, and you could see those tough conditions that it's in there. So regardless of condition, figure out what it is. And in the hot, humid southern region of the U.S., cattle with heat-tolerant characteristics are the ones that we look for. And your Brahman breed is going to be the Bos Indicus breed that is most commonly used. And it's going to be plugged into our composite breeds like we talked about, our Brangus and Red Brangus and Beefmaster and Cimbra. It'll be plugged into those. We also see a few Nellore cattle, but the Brahman would be the predominantly Brahman influenced breeds would be the most common here in the southern U.S. So why not purebreds in a commercial beef cattle operation? Well, we crossbreed for two main reasons. One, breed complementarity. So why did we cross the Red Angus with the Brahman? Well, to get the maternal aspect and marbling, easy fleshing of the Red Angus with the heat tolerance and adaptability and longevity characteristics of the Brahman. We put those together and we complement them. So we offset maybe some of the lower marbling of the Brahman, but we also offset some of the lower heat tolerance of the Red Angus. And so we put those together to figure out what breed works well in these environmental conditions. The other reason we do it is heterosis or hybrid vigor. And that is the result when the performance of the crossbred offspring exceeds the average of the parents. And so let's just go through an example here. So we've got, this is actually some data from Peacock and others from southern Florida. And I'll show you some McGregor, Texas A&M McGregor Research Center data that was done about the same time. But if we take this Brahman cow, and their Brahman herd at this research center averaged 399 pounds. And they also had an Angus herd, and the average weaning weight was around 404 pounds. And they crossed those animals. And the calves ended up weighing 428 pounds. If we would have taken the average of those two animals, we would have expected the weaning weights to be around 402 pounds. But we ended up with 428 pounds. So there was an extra 26 pounds of increase in performance and weaning weight because of direct heterosis, crossing those two animals. And some of that is increase in growth, but because of combining those two and the heterosis effect of that, but also we increase the survivability of that animal through hybrid vigor and heterosis. And with that, if you have an animal that does better, and that is more hardy, it's going to perform better. Same thing is those animals, if that animal is more suited to that environment, we're going to see that increase as well. So the direct heterosis effect there. Now we take those heifers, and these researchers did, they took those heifers, those F1, first cross Brahman and Angus females, and they put them back into their cow herd. And they used some matings there to keep everything fair from a research standpoint. And what they found is the benefits of maternal heterosis. And so that maternal heterosis can be an improvement in reproductive performance, an improvement in longevity, survivability, all of those factors. And so this particular study in '77, they looked at and they had looked at the Brahman Angus dams, the straight Brahman dams, and the straight Angus dams, and compared those three, looking at the weaning weights and fertility of the subsequent generation. And so they come up with, and we're going to show you a figure here of 440 pounds of calf per cow exposed. And what that 440 pounds is of calf per cow exposed tells us, one, the growth of our calves, how much weight that they were, but then also the reproductive performance of the cow. So how many calves that we saw out of those cows and what was our fertility rate of them. So we had 440 pounds on the Brahman Angus, 326 on the straight Brahman dams, and 271 on the Angus dams. The reason the Angus dams were probably so low is because of the environment they were in. They were in a more tropical-based environment where you had animals that were more suited to a cooler, more temperate type environment. Same thing with the Brahman dams. So if you compare the average of the Brahman and Angus dams to the performance, the average of the Brahman Angus dams, there was a big difference in pounds of calf per cow exposed. And there was a 47% advantage in the crossbred over the straight bred with this Bos indicus, Bos taurus cross. Now we'll show you here in a minute where if you take a Bos taurus breed and mix it with a Bos taurus breed, you're actually going to only have about 23% advantage. But because the Brahman is Bos indicus and is so dissimilar in its genetics to the Bos taurus breeds that we used, and this study was Angus, and phenotypically, if you look at those animals, they're two different beasts. I don't care if you paint them the same color. That differences there gives you that tremendous level of hybrid vigor there. And that's one of the big advantages that we have in Brahman-influenced cattle and utilize them in the crossbred scenario is because of that tremendous hybrid vigor. All right, so as we move into this next slide, as you can see, this was a study done at the Meat Animal Research Center in 1974, and they looked at, again, the effect of heterosis for weight of calf weaned per cow exposed, similar to what we saw a while ago, but they utilized Hereford, Angus, and Shorthorns in these crosses. And as you can see, those are all British breeds of cattle, Bos taurus breeds of cattle. And if you looked at the percent increase for a straight bred cow and crossbred calves, there was about 8.5%, or about 17%, or half of what we saw in the Brahman Bos taurus breeds that we saw earlier. And then if you look at the crossbred cows and crossbred calves, there was a 23% advantage there, which is about half. Around 47% was the Bos taurus, Bos indicus hybrid vigor level. This is half when you go with Bos taurus, Bos taurus. And so where does that improvement in weaning weight per cow exposed come from? The straight bred cow and the crossbred calf, again, on Bos taurus is at 8.5%, Bos indicus, Bos taurus is 17%, but calf survival and hardiness and calf growth. The crossbred cow and crossbred calf is calf survival, growth, reproductive efficiency, the hardiness, and we also have to throw in another factor of longevity. We know that those crossbred animals will live longer in that herd, and a lot of it is because of the hardiness and survivability of those cattle. This is the McGregor data utilizing Brahman and Hereford genetics, and as you can see there, if we look at the F1 heterosis there, calf crop weaned and weaning weight, and look at that, 396 pounds versus 275 pounds of calf per cow exposed, which equates back to around that 46, 47% improvement in pounds of calf per cow exposed. So two different studies there, one in McGregor, the other one we saw was in Florida there. So what I always tell my producers here in Texas is a discount of $1 to $2 a weaning for a little bit of Brahman influence, worth maybe more than additional 30 to 50 pounds of weaning weight per cow exposed. But then also, hopefully, maybe some lower production costs too. And so again, you've got to think about that original slide when we took at what our production costs are, the economic model, production cost, and how do we get a value of our calves? How many calves we have, pounds at weaning times price at pound. Those three factors multiplied together minus our production costs. So think about the genetic and what we do with that.